Hey, I'm Matt. This is Caleigh, Ryan, and Brad. Got their names right. And we're here to talk about modeling driver behavior in Winnipeg for plug-in hybrid electric vehicle, or we'll keep calling them PHEV, optimization. So we're here because of Auto 21, which is a national center of excellence, so that's what the Harper government calls it, dedicated to improving all things car related. So that's from everything from making the seats nice and cushy to what we do, which is monitoring driver behavior, specifically to optimize the batteries and how plug-in hybrid electric vehicles can work. So here, actually at the University of Winnipeg, an initiative funded by both the province and the university was to sort of have a pilot project of this low-speed electric vehicle. So it is really slow, but it is sort of an interesting opportunity to see how it works. And to be honest, there's been some complications so far, and maybe we'll get to that later, but can this technology work? Is it feasible? That's what we're trying to find out. So we'll talk about three things today. First, although even Danny said we couldn't, we're gonna whine for a bit, and we're gonna try and figure out what problem we're trying to solve. We'll talk about how we tried to solve it and what did we learn. So yeah, here we are with the vehicle, and he couldn't make it today, but Dave Capelle also did a lot of research, close enough. So yeah, to start off with a little bit of whining, there's obviously many contributors to this problem. Gas prices are getting out of control. They're not going to go down anytime soon. Localized pollution, air quality issues in larger cities, and the social consequences of car culture continue to be a problem. Peak oil is maybe our generation's largest concern. If you are under 50, you should be really worried, although perhaps it was only trumped by the climate change we are experiencing, global warming as a result of increased greenhouse gas emissions into the atmosphere. And here we see in the Canadian case, it's actually the largest piece of the pie is transportation, the emissions as a result of our transportation systems. And so obviously we need a change in energy source. We need to find out how we can power our same systems with a different source. So, naturally we think of a sustainable source of energy, or at least we call it sustainable, not to get to the problems with hydroelectricity, but even now hydroelectricity constitutes a very small piece of the energy pie, if you will, for Canada. And we're still dominated by fossil fuel and other very dirty sources, not to get to the United States addiction to coal as an energy source. So that's enough whining.
So you might ask where this car culture we have today came from. You might say it came from the 60s, the muscle car era. Big V8s, gas was pretty cheap, and people didn't really care about fuel economy. And this idea kind of carried on, and you may think the city design today, North America, where you have the suburbs, they're far out because cars are a big part of our lives now. And we get this in urban sprawl, so we have these concrete jungles that are formed now. We've tried electric before, though. This is an example from about 100 years ago that resides in the Smithsonian Institute now. Unfortunately, at the time, it lost out to other technologies such as steam and the internal combustion engine. They're just more practical, cheaper, so people went to those instead, and these went to the wayside. But if we go to the 90s, General Motors tried electric on their own with the EV1, but unfortunately, due to costs and other concerns, this project got scrapped and all the cars were destroyed, and it fell back into the wayside. But they came back and tried again with the Chevrolet Volt, which just came into the public eye a few years ago. But this car still has some of the costs that was seen earlier with the EV1, or concerns, sorry. So the cost, for example, $42,000, it's quite a bit of money. Other things people talk about often are the cold. Will the cold have an effect on the battery life? And some people even draw comparisons nowadays to the gas mileage to a high-tech ICE, like internal combustion engine, where the fuel economy is pretty much the same, so why go with a hybrid? And even just recently I've seen Mazda advertising that they have hybrid crushing fuel economy, so these things are kind of affecting this. And then reliability too. This is a $100,000 Fisker Karma that's being towed away. It's not even 200 miles into its test cycle, Consumer Reports. This model has had numerous battery issues, software glitches, things like this. People kind of get concerned about it and makes them shy away from the technology. Finally, we have to consider the infrastructure too. There's been estimates that to upgrade your home to accept PHEV or EV charging could range in the hundreds to thousands of dollars. And as well, in public, if we're going to be doing this in public lots, some people cycle the power or they limit it entirely, so it'll be ineffective there as well. But regardless, there's a lot of manufacturers that are jumping onto this progression. You see a lot of the big names, Toyota, Honda, Ford, GM, but we also have smaller ones such as BYD, which is Chinese, and we even have a company in Quebec called Zen, which has developed some technology as well.
Okay, so clearly, before you all run out after this presentation and buy an electric car, two things have to be addressed. First of all, are they going to work in Winnipeg, where it's cold? And second of all, can we optimize them to take full advantage of their environmental potential? So we started a really cool project. We took 100 of these auto GPS units here. They're actually manufactured by a local company called Percentec. And we put them in volunteer vehicles, people who live in the city, people who live outside the city, and we track them second by second, their speed, their location, for a full year, with their consent. And we were able to come up with how people drive. So specifically, what does that average home-to-work trip look like? What are the speed and acceleration demands of the trip to go pick up the kids from school? And how does that differ for different trips throughout the day? For instance, that trip in the evening to go pick up groceries or to go watch a movie. In fact, we can come up with a total distance and a total duration, which is the average amount that people are driving their vehicles in Winnipeg. We call that the Winnipeg duty cycle. We use that Winnipeg duty cycle to determine how much energy it takes to power our cars. For example, we can take a mid-sized sedan, and we can load it up with a driver, passengers, and cargo. And we can use some fancy physics to determine how much energy it takes to overcome the weight, the friction, and the drag. We can package that whole thing up, and we can throw it on the Winnipeg duty cycle, run it a couple hundred times, and that tells you how much gas, how much electricity it takes to run that car through a whole year. And then we can alter it. We can take the differences between summer and winter. For instance, idling goes way up in the winter when you're heating your car up or when you're cranking the air conditioning in the summertime. And in the end, we get really cool numbers. So the first row there, CV, stands for conventional vehicle. That's just a gas-powered car. On our model, that gas-powered car gets about 15 liters per 100K in fuel economy. Now take a plug-in hybrid electric vehicle under the worst conditions, minus 30 degrees in a snowstorm, and we're still using about half the amount of gas. But we can do even better. We want to see zero gasoline usage. So we look at other things too. Using all that GPS data, we can figure out where people park in the city of Winnipeg. And these places might be ideally suited for recharging infrastructure, so you can top up your charge throughout the day. So take the University of Winnipeg, for instance. Think how cool it would be if while you're attending class, your car is charging while it's parked on the street. And we can go into a lot of detail with this. Here's Grant Park Shopping Center. And all the red dots are people who have parked to go watch a movie. So this is in the evening typically for 2 to 3 hours. And in the evening, electrical demand is quite a bit lower than during the day. So maybe Manitoba Hydro could give you an incentive, charge you less for the electricity that you're using.
So as you can see, there have been a number of projects that our research team has been working on in the past 5 years. Everything we have studied has been for the purpose of furthering our knowledge on how our current transportation systems work and what future transportation systems may look like. We've looked at how people drive, where they park, what kind of power they're demanding from their vehicles, how weather impacts their driving, where it makes the most sense to install these recharging stations, and what the potential costs of driving PHEVs in our city might be. But there's still so much to learn. The point of all this research is to better understand these systems. If we're going to think about making the transition to a fossil fuel dominated network, or from a fossil fuel dominated network to an electric one, we have to make sure we're making smart decisions about that transition. There's still so much to learn about different aspects related to transportation. Research thus far, including our own, has only been the tip of the iceberg. It's going to require a lot of energy, money, and time before we come to a point where we can confidently say that yes or no, it is or isn't worth it to make this transition. Will the environmental and cost benefits be grand enough to make it worthwhile? Again, there's still a lot to know. And yet, I feel as though I can speak on behalf of our entire team in saying that we think there might be a simpler answer out there, to be honest. Something sitting right in front of us. All of this research that we're doing takes time, money, and a lot of effort. Why not spend that on a solution that we know works? That's proven to work in countless other cities throughout the globe. To be honest, despite us having summer jobs in the electric car research industry, we believe that people shouldn't hold out for the electric car. We believe that it might not turn out to be worth it anyway. Let's invest in solutions of public and active transportation. We already know they work. Not only do they solve issues of global warming, pollution, peak oil, but also human obesity rates, problems of space and city planning, just depression and healthy living and standards in general. So in conclusion, our team would like to challenge you to think outside the box. Don't hold out for the electric car. Try riding your bike. Try taking the bus. Encourage your government representatives to invest in public and active transportation. Let's not wait for the solution. Let's make it happen now. Thank you.